Okay. This is 9.2.3 solving by graphing and factoring. This is a continuation of one of our lessons. This is actually the last lesson we have before the quiz. This is for Tuesday, March 25th. Okay, so for my first period that's going to be watching this video, make sure that you're taking all the notes down. For third period, you may need to do this. I'm not sure quite yet exactly when I will be back. Um, but more likely than not, you will probably have to watch this. In any event, we will look at all the components that we need to, and we'll start with the do first. So here it says that we need to simplify each polynomial expression. Your final answer cannot contain any negative exponents. Okay, so we've had so many issues, so many different kinds of issues with our exponents and exponent rules. Make sure you have your reference sheet handy with you. You can grab one from the back shelf. They are pink for us as well, so they're very easy to identify. But I'm going to look at the first 6 problems here. My recommendation is before I get into a problem, I suggest you try it out yourself. So like for particularly let's do first, I would say try it yourself first and then see where you need help and go from there. But with this first one, I'll go ahead and do it. I see that I have a 2. I see I have a 2 to the power of -2. Remember, if we have a negative exponent, you have to flip over your fraction. So if I have a 2 in my numerator, that means it's going to go into my denominator. So I have 1 over 2 squared. As soon as I flip it over to the reciprocal, I'm going to drop that negative. I no longer have a negative now. And so I will then get my correct answer of 1 over 4. Now, keep in mind, that is only for the 2 to the -2. I still have the m to the -3 and the n to the 0. So I'm going to kind of break it apart like this because we don't actually have any like variables or like numbers, at least for the most part. So really, we don't need to do all this extra stuff. We can just be fine with doing this this way. So I have 1 over 4 for my 2 here. Then if I look at my m to the -3, again, that negative exponent, I'm going to reciprocate it. I get m to the positive 3 in my denominator. Okay, so make sure you have that down as well. However, if I have n to the 0, that of course is going to just be 1. Okay, anything to the 0th power is just going to equal 1. There is no real math here, just know that anything to the power of 0 is 1. But having my answer split up like this is not the correct way to have this done. So once you find all of those 3 components there, you're going to make sure you multiply them at the very end. So if I have 1/4, I'm going to multiply 1 over m to the 3rd, and then also multiply the 1. The 1 is just there for formality since otherwise you don't need it. Okay, but you're going to multiply as you need to. I get 1 over 4 m to the 3rd, and that is my first answer there. Then you keep going, and again, you should try these on your own. But just for time's sake, I'm going to not necessarily blitz through these, but I'm going to kind of verbalize and show you how I'm getting these answers rather than breaking it all the way down like I did with the first one. So with 10 to the 0, of course, that's going to be 1. So I know that's basically nothing. I see that I have r to the -11th. So that means I'm going to put it in my denominator. So instead, actually, I'm going to kind of cross out this 10 to the 0 because I don't need it anymore. And then I have the -11. Go ahead and take care of that. And I'm going to put it down here. I see s is by itself. There's no exponent. Therefore, we need to think about it as exponent of 1, which nothing's going to change there. Last but not least, I have my 3 squared. I have, well, 3 times 3. That gives me 9. Therefore, my answer should be s over 9 r to the 11th power. Okay, so there it is. Moving forward, I see I have a number 3, 4 to the -3rd power. I need to change it to put it in my denominator. So I'm going to say, well, 4 to the 3rd power. I see I have a to the 0th power. That is just going to be 1. I can cross that out. That's pretty much done and over with. But then I have b to the -7th in my denominator. I need to move it up to my numerator. So b to the 7th over here. But don't forget you need to simplify. So 4 to the 3rd needs to be simplified to whatever that number is. 4 times 4 times 4 is going to be 64. And that is question 3 done. Question 4, same deal here. I see that I have a -8 for my exponent. That means I'm going to put p on the bottom, p to the 8. Then I have 7 to the -2. That's going to go back on top to be 7 squared. And I see the same thing for my q to the -9. I'm going to make sure that I have -9 for my exponent. Sorry, +9 because I changed it. Right there. And of course, simplify as necessary. 7 squared is going to be 49. So 49 q9 over p to the 8. A lot of different looking kind of numbers and letters there. So don't be too confused. Then 5 and 6 are going to be a bit more challenging. First part I see is 2 squared, which is going to be 4. Then I see that my y to the -6 in my numerator is going to go back down to my denominator. 8 to the power of -1 is going to go on top. But be careful here. It's not going to be 48. It's going to be 4 times 8. So make sure you know the difference between those two. It's going to be 4 times 8. Then the next part I see is going to be 0 to the 0. Sorry, 0 to the 0. Z to the 0th power. That's going to be just 1. So basically you can ignore it. Then I'm left with x to the -7. That goes on top. And of course, I simplify. 4 times 3 is 32. X to the 7th over y to the 6th, just like so. Last but not least, I have my 13x to the -5th, y to the 0th, over 5 to the -3rd, z to the -10th. Okay, that's a mouthful, but we'll be fine. Here, I see the 13 is going to stay at 13, nothing special about it. My x, however, is going to go in the denominator. My 5 and my y to the 0th is just 1, so I'm going to not deal with anything and cross it out. 5 to the -3rd is going to go on top and make sure I multiply. Okay. Last but not least, I have my z to the -10. That's going to go in my numerator. Make sure you're doing the multiplication correctly. It's 13 times 5 to the 3rd, in which case you should get an answer of 1625 z to the 10th over x to the 5th. Okay, so again, make sure you're doing all of that work done correctly. And now we'll get into the real part of our lesson today. And we're going to first look at our Explorer. For each quadratic equation, convert the equation into a function. Example, x squared minus 9 equals 0 will turn into a function of f of x equals x squared minus 9. We're going to sketch a graph of the graph of the function, and then use the graph to solve the original equation. Okay, so if I'm looking at my problem here, I'm trying to figure out what the solutions are. I essentially need to figure out what x equals. Okay, well, luckily for us, I'm able to do this by just graphing this into my calculator. So if or even just, like I said, sketching the graph on my function. Well, if I go ahead and try to sketch this, I see my graph right now is x squared minus 4. If I make this into a function, it turns into f of x equals x squared minus 4. And I can use Desmos to help me here in order to go ahead and graph that. So with my nice iPad here, I can go ahead and do that for us. So looking at Desmos, and this is all the work from previous lessons. So let me go ahead and clear all that out. There's a ton of stuff there. Go ahead and put x squared. And then it is a -4. And I can see exactly where my graph looks. So I'm going to look for my key information. I'm going to look for my x-intercepts, and I'm going to look for my y-intercepts, and I'm going to make sure I plot those correctly. So my y-intercept, my vertex in this case as well, is 0, -4. And my two solutions, my x-intercepts, are going to be positive and -2. So I'm going to do, to the best of my ability, a curved line there. But what this allowed me to do is say, well, I know what x squared minus 4 equals 0. I know what the solutions are by looking at my graph. So x equals 2, x equals 2, and x equals negative 2, which of course you could have represented as plus or minus 2 as well. Now that one was easy, right? That's an easy one. But the next one is not as easy. So we'll see that in problem 2, it's a little bit trickier. Okay, well, we can go ahead and try it. So I have x squared. I'm going to see how I can convert this into a function. And in doing so, I get f of x equals x squared plus 3x. So I'll plug that into my Desmos. And this is what I get so far. My vertex is negative 1.5, negative 2.25. So to your best of your ability, kind of estimate where that point would look like. But then I need to figure out what my x-intercepts are. I get negative 3 and 0, 0. And I should have a graph that looks something like that. So my solutions here are going to be x equals negative 3 and x equals 0. To me, at least this seems pretty nice and easy so far. Now with problem 3, however, this is where it changes a little bit. Okay, notice how in the previous problems we only had 2 terms, now we have 3 terms. So we need to figure out how to deal with this one. Well, same exact approach. I'm going to change this to a function. I get x squared, minus 2x plus 1. I can go ahead and graph that in my Desmos. Plus 1. And I'm going to find my 2 pieces of information that I need, my x and my y intercepts, like it shows right here. Oops. So I'll go ahead and graph that, 0, 1, and 1, 0. But notice here that it doesn't actually go twice through the x-intercept, or through the x-axis. So really, I only have one solution, and my graph will look something like that. So, whereas the previous 2 questions, I had 2 solutions, this one I will only have one solution of x equals 1. Okay. And then at the bottom here, it says after you find a solution graphically, you can check your result algebraically. That is true. If you plug in those values for the problems that we found, you will get a answer of 0 back. And that's whenever you know you've done it correctly. Okay. So that's kind of a way for you to check your work. Now, for key point 1, right, it says that the quadratic equations can be solved graphically by graphing the related quadratic function and looking at the x-intercepts. Okay, you can use the x-intercepts, you can say the zeros, you can say solutions, whatever kind of word you need to trigger your mind to say, oh, whenever it crosses the x-axis, that is what you're going to use. But here's something to note, though. Before graphing the related quadratic function, the equation must be equal to 0. If it's not equal to 0, it will not work the way you want it to. So make sure you solve it to equal 0. And we'll see some examples. Here it says, for each graph, identify the zeros on the graph. Well, if I'm looking at this correctly, the x-axis is right here, that orange line there. But my graph is this green graph. So because I see clearly that I am not going to touch this x-axis, I can say definitively that there are no solutions here. And I know that for a fact. But in question 2, if I see that my x-intercept, sorry, my x-axis is right there, and my graph is green here, I see very clearly that there are 2 spots where I intersect at. This red one and this red one, where x equals -5 and x equals -3. So for my solutions here, there are 2, x equals -5, x equals -3. And that's what I get for that question. Go ahead and try these 3 problems with a partner or do it by yourself, whichever way you prefer. Just make sure you're doing the work. I'll give you some time for that. Just pause the video. And then you can unpause it and see from here. If I look at the graph of f of x equals negative x minus 1 squared minus 2 with this first one I'm looking at right here, when I solve the graph, I see the equation has 0 solutions. And there is a reason for this. Well, the reason is very simple. Because the graph does not the x-axis. Very simple. Then I look at this one, graph number 2. Well, I see clearly that the equation has 1 solution because, well, the graph touches the x-axis only 1 time. So unfortunately, it only touches it 1 time, but it still touches it nonetheless, more than the previous. Lastly, I see that this is going to touch twice. So the equation has 2 solutions because the graph crosses the x-axis twice. So make sure that you're doing that correctly. Now, in Explorer 2, it says that Marvin was solving the quadratic equation. 2x minus 1 times x minus 3, or x plus 3, equals 0. He first graphed the related quadratic function and then looked for the zeros. How could Marvin just solve this equation without graphing? What are the solutions to this equation? And then justify your answer. Go ahead and try this. See if there's any other way that we've learned in the past. Hint, hint, wink, wink. There's definitely a way that we've learned in the past to be able to do this. But go ahead and try that now. And then you can unpause and see what the actual answer is. So the thing that we should have noticed here is that this equation is written in factored form. So because it's written in factored form, so you can solve for solutions. Oops, I can't spell. By 2x minus 1 equals 0 and x plus 3 equals 0. And when you do that correctly, you can find the x-intercepts of x equals 1/2 and x equals -3. Let me rewrite that. -3. So make sure that you are doing that correctly. Okay. Under explain 2, we have some fill in the blanks that we had to note. Key point 2 says quadratic equations can be solved by factoring. So make sure you know that you can be factoring. Before factoring, always set the equation equal to 0. If you do not factor it all the way to 0, it is not going to give you the best answer. Okay? It'll give you an answer, but it won't give you the answer. Okay? Now to clarify, this is something we should already know. We already know this skill. Okay, so make sure that you are incorporating the skills that we've learned beforehand, rather than, sitting there and idly waiting for an answer, like some of us have the tendency to do. Okay, so make sure you are in charge of your own learning and that you are trying your best and trying to learn. Okay. Now, teacher model 2, solving by factoring. Here we have a quadratic equation. We're going to factor the quadratic equation and determine the solutions for this equation. Then we will sketch a graph of the related function and identify the solutions to the equation. Well, I have x squared plus 4x equals 0. I already have it set equal to 0, so I don't have to do anything there. But I will see, is there anything in common between x squared plus 4x, or is there a factor that I can get out of it? Well, I notice that both terms have an x in it. And because both terms have an x in it, I can go ahead and take that out of I guess part of my equation here. Kind of think about it again. I'm not changing my answer, or I'm not changing my equation here. I'm just changing how it looks. They are still the exact same thing, though. Yeah, they are still the exact same thing. And from here, when we learned about factoring, we said that if I get a situation where I have a factor times a factor equals 0, split them up. I have x equals 0 and x plus 4 equals 0. Because the goal, again, is to figure out what values of x give me 0. Well, luckily for me, one of them is 0, because if I multiply anything times 0, I'm going to get 0 as a result. So x equals 0 is one of my solutions. But I do need to solve for the other one. So I will subtract 4 on both sides. I get x equals -4. Now, I am not too worried about your graphic skills in this case. I really just want to make sure that you understand how you can find these and how to graph at least the intercepts. So I get 0, 0 because of x equals 0, and x equals -4. That's going to be my other point. So it's right there. Okay. If you want to be more specific, you can go to Desmos and just go ahead and graph it as you normally would. So x squared plus 4x, you can see that we do get the correct zeros. But if you would like to do the correct vertex as well, that's probably another good point, I would say, to help you graph it. But again, I'm not looking to see if you graph this correctly. As far as the whole graph, just make sure you graph the x-intercepts correctly. But the vertex is still pretty helpful. So if you're going to graph anything else, I would say graph the x-intercept, or sorry, graph the vertex. Okay, then number 2, very similar situation. However, I see I have -x² equals -2x plus 1. Well, I need to get this to where I have a equals 0 somewhere, either on the left side or on the right side. Now, personally speaking, I don't like having a -x² or negative leading coefficient. So instead of moving -2x plus 1 from the right side to the left side, I'm going to move it the opposite way. I'm going to move x² to the right side from the left. So my equation would then be 0 equals x² minus 2x plus 1. Like so. Now, luckily for us, this is an easy equation to figure out what the factors are for. And the factors we should get is going to be x minus 1 and x minus 1. Because this is that, what was it called? The perfect square trinomial, right? Because I have a perfect square in my leading coefficient, perfect square in my C term, and then the middle term is twice as big as the multiplication of A and B, which was the 1 and 1 there. So I know that sounds really confusing. Use your reference sheet if you need to. But as soon as I get it to x minus 1 times x minus 1, I don't really need to multiply, or I don't really need to figure out two separate factors because I only need one of them, right? So I'm going to put x minus 1 equal to 0, and I end up getting x equals 1 as my solution. So again, go to my graph. I only have one solution. I'm just going to kind of estimate where my graph would look like possibly, and I'm just going to say that. Okay, as long as they are facing the correct direction, it does not really matter. However, actually, now to think about it, I would say instead try to do it with Desmos anyways to make sure you graph it correctly. So if I have x² minus 2x plus 1. This is what my graph looks like. So this is probably the more accurate graph. And I'm going to follow by what it says. So 0, 1, and 1, 0. Your graph looks something like that. And that's probably a better representation than what I had shown you. Next one here, we have 3x squared minus 7x plus 2. Now, the easy cop-out way to do this is to use your Desmos. And it really is. It is so easy to just do that. Plug in 3x squared minus 7x plus 2 into your problem or into your Desmos field and just solve it like that. It is so simple to do that. But I know I've taught y'all better and you know how to solve for this. Yeah, I know you know how to factor this because we've shown that we can do it. So when we are factoring here, I know that I have 3 and 3 is my A and 2 is my C. So I'm going to factor this by multiplying 3 times 2 to get 6. And I start with my factor tree. 1 and 6 and 2 and 3 multiply each other to get a positive 6. However, because I have these answer choices, I need to somehow add up to a negative 7. And the only way to me to add up to a negative 7 is if both my 1 and my 6 were to be negative. So if I add negative 1 and negative 6, that equals my negative 7. And that's what I want. That is true. But I need to make sure that they're negative because I need my B to match up correctly. So after I've done that, I'm then going to make my box. I'm going to plug in 3x squared into my middle box. I'm going to plug in my 2 in the bottom right. And I'm going to plug in the factors that I found right here in for those other boxes. So I get negative x and I get negative 6x. Okay. And then I find the GCF of the columns and the rows. Between my first column here, I see I only have an x in common. Between my second column, I see I only have a 2 in common, but remember we discussed that if I have a negative value for any of the values here, I need to expect a negative value to come out of it. So since I have 2 values that are negative, the negative 1 and the negative 6, I need to expect 2 negatives to come out as well. So instead of putting a 2, I will put a negative 2. Then I'll keep going with my rows. My GCF for my rows here is 3x squared and 6x. I see they both have a 3x in common. I will make a note of that. Then the last part here, I see I have negative x and 2. They both only have a 1 in common, but again, I need to expect a negative. My negative 1 will go there. So now that I've rewritten this equation right here, as a factored form, I can write 3x minus 1 times x minus 2, and that will equal 0. And from here, I can branch off. 3x minus 1 equals 0. X minus 2 equals 0. Go ahead and simplify as I need necessary. I should get x equals 1/3 on the left side and x equals 2 on the other side. So these two are my answers. They're my solutions. So x equals 1/3 is about there. X equals 2 is about there. I will kind of guesstimate the graph to look something like that. Okay. And again, I should, in theory, if I plug in my original 3x squared, right? So 3x squared minus 7x plus 2, I should, in theory, get the exact same equation as my factored form. So 3x minus 1, then x minus 2. So they theoretically should be right on top of each other, and it does look like they are right on top of each other. That's how I know that they have been done correctly. And if I look at my graph, I get 0.333 repeating, and I get 2.0 or 2,0. That is the correct graph. Okay. So again, I told y'all that you know better. You know how to factor these numbers out. You know how to factor all of these polynomials here. You do. I know you do. So I really want to push y'all to only do it that way. Okay? Only do it that way. However, of course, please check your work with Desmos to help you there. Okay? Desmos is here to be a tool, not a crutch. Okay? A tool, not a crutch. Now, looking at my time currently, I am running out of time to record this video. So I will just go ahead and give you the answers for these 5 questions that I currently have left. And I want y'all again to try it using factoring and check your work with graphing. Okay. But you should have gotten x equals -1 and x equals -4 for the first one. That's kind of the easier one. You should have gotten x equals 3 for the second one. It's also kind of an easy one. Number 3 is a bit more difficult. So you may need a little bit more help there. But you should have gotten the answers of x equals 1/2 and x equals -1/3. Number 4, you would have gotten an answer of 5/2 and x equals 1. And number 5, you would have gotten x equals 5/2 and x equals -5/2. Something to keep in mind here is 4x squared minus 25. That is a difference of squares. Okay, so keep in mind that we know how to use difference of squares from our reference sheet. So make sure you're using the reference sheet to the best of your ability. Okay, now that is about all the time that I have. I will be uploading the key that I have for this unit so far in Schoology, so keep a lookout for that so that you can see these 5 questions actually done all the way through with the graphs, with all the work, with factoring, not specifically just using the graph, right? Graphing it correctly and with the correct work for doing it by hand. Remember, the calculator is a tool, not a crutch. Okay. Of course, if you have any questions, you can send those questions to me on Schoology. I will answer them as quickly as I can, or if I see you on Tuesday, I can answer that question for you. But otherwise, I hope you have a good assembly because I will not be here for the assembly. And then have a good rest of your day. Bye, y'all. See you later.